We're going to talk today about parallel and perpendicular lines and transforming linear equations. First of all, let's figure out what parallel lines are. These two lines are parallel. That means that they have no points in common and they're in the same plane. If you look over here, what do you notice about the slopes of those two lines? Hopefully you will notice that they are the same. Take a look at the y-intercepts. They're different. So we can conclude that parallel lines have the same slopes but different y-intercepts. Perpendicular lines look more like this. They cross to form 90-degree angles. Now, let's come up with equations for these. That's going to be a good review for us. So we need to pick some points on here that look like good points to identify. Those look like good ones to me. And we're going to write our equation in slope-intercept form. So we need two pieces of information. We need the slope and we need the y-intercept. So to find the slope here, we're going to go up to right 1, up to right 1, up to right 1. So this line has a slope of 2. Okay? So I'm going to put y is equal to 2x plus, and then I look up here to see my y-intercept, which in this case is 6. Let's look at the second line. Let's pick some good points. That looks like a good one. That looks like a good one. That looks like a good one. Any of those will do. And again, you go from one point to the other. You go up 1, left 2, up 1, left 2, up 1, left 2. So up 1, left 2 gives me a slope of -1/2. So this one's going to be y is equal to -1/2 x, and that goes right through the origin, which is 0. So you can either leave it like this or plus 0. What do you notice about these two slopes? Well, they look similar, but not exactly the same. In fact, they look like they are the opposite sign. One's positive, one's negative, and they're also reciprocals. So we can determine that perpendicular lines have slopes that are opposite reciprocals. So here it is all together for us. Parallel lines have the same slope, different y-intercepts. Perpendicular lines have slopes that are opposites and reciprocals. Now what are we going to do with that? You should be able to identify if lines are parallel to each other or are perpendicular to each other. And the easiest way to do that is by putting them in slope-intercept form. That means solve for the y and make it look just like this, and then compare the slopes. If the slopes are the same, but they have different y-intercepts, they are parallel. If the slopes are opposites and reciprocals of each other, then they are perpendicular. I'm going to also ask you, or you should be able to write equations for lines that are parallel or perpendicular. So let's say I give you an equation y is equal to -3x plus 2. So that's going to be the starting equation. If I ask you to write an equation for a line that is parallel to that, then you're going to come over here, you're going to look at the slope, and since parallel lines have the same slope, then you're going to use m equals -3 for the slope here. If I asked you to write an equation for a line that is perpendicular, then we know that perpendicular lines, their slopes are opposite and reciprocals. So again, I go back and look at the slope that was given to me. The opposite of that would be positive, and the reciprocal would be 1/3. So we're going to use a positive 1/3. Okay? Then you're just going to simply write the equation like you would. So let's go ahead and review that also. Okay? Let's say that I asked you to write an equation for a line that is parallel and goes through point 2, 7. Okay? Remember, the form that is best to create is point slope form. So I'm going to put y minus my y value is equal to my slope times x minus my x value. Okay? There it is in point-slope form. If you need to have it in slope-intercept form, you're going to do the distributive property. That's going to give you y minus 7 is equal to negative 3x plus 6. Add 7 to both sides. Y is equal to negative 3x, plus 13. If I ask you for ones that are perpendicular, again, our slope is 1/3. Let's say we ask it for a point that goes through 9, 5. Okay? Again, I'm going to set it up using point-slope form. Y minus the y value that we have is equal to 1/3 times x minus the x value that we have. If you need to have it in slope-intercept form, you're going to do the distributive property. You're going to get y minus 5 is equal to 1/3 x minus 3. Add 5 to both sides. Y is equal to 1/3 x plus 2. Okay, so a good review of a couple of concepts there. Now what I need you to do is I need you to get out your graphing calculator. If you don't have a graphing calculator, if you don't know how to use a graphing calculator, then get out a piece of graph paper so that you can graph these yourself. Okay, we're going to look and see what kind of changes happen. We're going to start with this equation right here, and we're going to graph it, or we're going to put it in our graphing calculator. Now, if you're putting it in your graphing calculator, you're going to go to your home and then go to graph. If you're already in the scratch pad, you're going to go back and forth. Just hit the scratch pad button back and forth, and you can go back and forth between being able to calculate and graph. You're just going to put in, you'll hit the tab button and you'll see fx1. And remember, that just takes the place of a y. So this is like saying this is the first equation and this is y equals. And you're going to put in an x and you're going to hit enter and it's going to graph it. And that should be a line that goes right through the origin. Now what I want you to do is hit the tab button again. This time f will pop up again with an x, but it'll have a little 2, meaning this is the second equation. I want you to type in x plus 2, hit enter. Look to see what the difference is. How did that second graph transform from the first one? And then I want you to hit the tab again. This will pop up the third one and type in this, and again, see what happens. I'm going to ask you a question about that in a minute. Now what I want you to do is I want you to clear that out. And you can do that by just going back and deleting, just arrow up and delete. Or if you hit the delete button a couple times, it'll pop up and it'll say, do you want me to clear everything? And just say yes. Now I want you to do the same thing over here. We're going to put the x in there for this one. Okay, we're going to put an x in here. We call this our parent function. That's the one that we start with. So, okay, so that's the one we start with. Then I want you to put in 3 times x for the second one. See what happens. What should happen is the lines both go through the origin, but one is tilted steeper than the other one. And then I want you to put this one in, which is 1/4 x, 1 divided by 4 on your calculator times x. And what should happen is this line should still go through the origin, but it should be flatter than the other two. All right, so I want you to think about this. All of those were in the format y equals mx plus b. On the first ones, when we changed this value, what happened? How did it transform? How did it change? When we changed this value right here, what happened? Okay, you need to know those.